Alright, so the Laplace of e to the 5t Alright, so integral 0 to infinity e to the 5t e to the negative st dt. So that's e to the negative s minus 5 t dt, which, using our little u sub technique we've done many a time, it's going to give us a negative over negative 1 over s minus 5. So negative e to the negative s minus 5 t over s minus 5. Evaluated it from 0 to infinity. And that e term is going to simply simplify down to 1. So we're left with 1 over s minus 5. All right. So for a linear combination of functions, we can evaluate it separately, and we can essentially break it up into functions that go from t in terms of s. So the Laplace transform of alpha f of t plus beta g of t the alpha, since it's a linear transformation, you can think of it kind of like we can factor. So we can factor out the alpha outside our Laplace for f of t, and we can factor out the beta outside the Laplace of the g of t. And since the Laplace transform simply converts a function in terms of t into a function of terms of s, then our final result is going to be that s function for both b and for f and g. Okay, and I made a mention that this idea of a Laplace transformation is similar to a limit. Like, there are shortcuts coming, and once we understand kind of what that does, we can look at general patterns. And so you can kind of see this chart here where we've done a few of them, but we haven't done all of them. So we've done the Laplace of a constant, so Laplace of 1, which is just 1 over s. And we did the EAT, so that's the C in the chart. So we did that one, which gave us that S1 over S minus A. These other ones we did not derive for you, and we're not going to. I'm just going to give you the pattern, and we'll just use it to answer questions. So the Laplace of sine of kt is going to be k over s squared plus k squared. And notice there's a parallel between sine and sinth, and then cosine, and you can probably guess what's missing there. So that's the Laplace of the cosh function. And so you can see there's some nice parallels with that. Okay, so for the Laplace transform for 1 plus 5t, remember that whole linear combination thing, we want to separate it out into individual terms, and then if we can, essentially factor out a constant outside of the Laplace transform. We want to do that as well. So the Laplace of 1 plus 5t, we can split that up as the Laplace of 1 plus 5 times the Laplace of t. Okay, so then we go to our chart and we just look at, well, what is that? Well, the Laplace of 1, that's 1 over s. T, so let me kind of just remind us of what that one is. So if we look back at our chart, we're looking for that one that has an exponent on it. So that's the Laplace of t of n. So n in this case would be 1. So that would be 1 factorial over s to the 1 plus 1, which is 1 over s squared. So that 5 Laplace transform of t would be 5 times 1 over s squared. Okay, in this next example, let's separate them out into their different terms, and if we can essentially factor something out, let's do it. So we can pull a 4 out, and then we have a pattern for e to the 5t, and then the 10 we can pull out, and we have a pattern for sine. All right, so that's going to be 4 over s minus 5, and then 20 over s squared plus 4. All right, so last one of these we're going to separate out. So we got 20, then the Laplace transform of e to the negative 3t. Then we take the 7 out, and we have a transform for t, and then we can take the 9 out, and that gives us a transform of 1. Okay, so if we go back to our chart and look at what to do in those different cases, that should give us a 20 over s plus 3 plus a 7 over s squared minus a 9 over s.